I'm Ashley, and it is good to be with everyone tonight. So I'm teaching fourth grade again this year, and today I introduce for the first time multiplication with 2-digit by 1-digit numbers, which isn't really very hard, but I really try to teach this conceptually because even though my students might be able to give a correct answer, I want them to be able to understand what they're doing, and it's a lot easier for me to teach this with the 2-digit numbers rather than when we get into the 3-digit and 4-digit and then the 2-digit by 2-digit numbers. This is a great opportunity to teach different forms of multiplication. I like to start by using counters. I don't have enough counters at home to model a larger problem, but just for an illustrative purposes, I'll have my students make arrays. So for example, this may be 3 groups of 6. So what I want my students to see, and we use the two-sided counters so that we can point out the distributive property, because this is really the same as 3 groups of 2 plus 3 groups of 4. And we do a handful of problems just with the counters just to begin illustrating the distributive property. I don't use numbers that are super large just because we don't have time to make a bunch of these, but this is a good introduction. Once I feel that students are really comfortable with the concrete, with the manipulatives, with the counters, then we move into using chart paper. Now I'm pretty sure this is going to reverse some of my images and writing, but I think you can get the gist. What we're doing now is we're creating the same type of array, but we're just going to color it on grid paper. So for example, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 1, 2, 3, 4, 5. So I have 5 rows of 15, but what I want my students to see is that this is really just 5 plus 10. And like I said, I know things are distorted, but I think that you can get it from here. I also like to draw the array using the 2 different colors and then have my students tell me what multiplication equation could be represented with this array. Introducing the area model. So I draw this array. We have 3 groups of 14. So I asked my students, how could we break this up into manageable multiplication problems where we're working with facts that we know? Now obviously you're going to have 1 or 2, oh, I already know it, but just say, that's not the point. That's not what we're working on right now. So we want to guide students into realizing that we could just have 3 groups of 10. Let's make sure I have 10. Here's an array of 3 groups of 10. And then we also have an array of 3 groups of 4. And then there's typically students' first experience with an area model. And then I guide them into saying, guys, is it always going to be necessary for us to draw every single dot? No, let's use numbers just to represent those dots. So with some practice, I then guide students into beginning to understand how to draw an area model on their own. And we just do a lot of guided practice together. So say I might have students take out their dry erase boards and say, okay, well, let's try 4 times 17. So we think about, well, how can we break apart 17, which would be 10 plus 7. So students need to understand we're going to multiply the 4 by the 10 and the 4 by the 7 because we're making an array of 4 by 17. But this time, rather than actually drawing the dots, we're just going to use numbers to represent. So we know we have 4 groups, and we know that there's a total of 17 in each group. So I could assume, well, this is probably about 10. Does that look like? Yeah, 10. Okay. So this is 10. How many is in this row? Oh, okay, 7. So then let's ask the students, so if I have 4 groups of 10, how many's in this area? And then, of course, they would know that it's 40. Well, what about if I have 4 groups of 7 here? And then ask students, so what do I do with the 40 and the 28? How do I combine them? And, of course, you're guiding students into understanding that you just add the 40 and the 28. Now, on the day I introduce this, I do like to go ahead and talk about the distributive property just because I think it really helps students make that connection. I had so many students today go, oh, so that's why it works. So when we're doing the distributive property, I would use these models to say, can you guys think of another way we could write this? So we would just go then say from this one, if we go back to the 4 times the 17, so I might say, okay, so what if we don't want to draw an area model? What's another way we could do this? And then I'm going to guide students. We'll talk about parentheses. I say just think of it as something you could hold in your hand. We're separating the groups to let us know what we're doing first. So we would have 4 times 10. Then we have to remember to close the parentheses. We talk a lot about not letting parentheses confuse ourselves because students have a tendency to see the parentheses and just kind of shut down. And then we're going to add that group to our 4 times the other 7. Or, sorry, not the other 7, the 7. And then we look at how we can know, well, that's 40, and this is 28. And then students make the connection of, oh, that's the same thing. Now, I don't teach partial product today. Tomorrow I will be reviewing all of this, and then I'll add partial product into the mix. Then after I add partial product into the mix, I'm going to wait until my students have a really solid understanding before I introduce the algorithm. Where students are doing multiplying two-digit numbers, the context of the problem will be in a comparison. And then I want students to show me 2 different ways to solve each of the problems. For my students, I will require them to show me with the distributive property and with an area model. Typically what I'll do is I'll do these 2 with the students. And then on these 2, I'll let them do it on their own or with the partner, and then we'll go over them together in a group, and then I'll use these 2 as kind of like an exit ticket. So students are going to try these independently. I always make a big deal out of, it's your first day. If you get it, great. If you don't, that's fine too. And then I use those last 2 just to know where to go with my instruction. Typically, I had at least 50% of my students get it. They rated themselves a level 4. They said, we're good. I had a lot rate themselves a 3, and I had a few rate themselves a 2. But then when I checked what they did, I found that I did have some students who are still probably 1s and more 2s than what they thought. So tomorrow during our workstation time, I'll be meeting with those groups to build them up on this so that Friday when we do a more problem-solving task, they'll have a better understanding of how to solve these problems. So hopefully this has helped you a little bit. I know 2-digit by 1-digit doesn't have to be this complicated, but it's just a great way to begin developing a base of conceptual understanding of multiplication. So when we do get to these larger problems, they understand the flexibility of how we can problem solve in different ways and think about math differently. So let me know if you have any questions. Thanks.